similar related one. Which lamps generate the least pollution? So, okay, this is a really simple, straightforward, logical question, but it's actually a painfully complicated answer because it totally depends on the kind of question that would actually be coming at you. My guess is that the simplest answer to this would be the LEDs. That the LEDs have, because they're very efficient, generally, because they're sort of small, you can put them very close to the place where you want the light. So you can actually, not only are they efficient, but you can use them efficiently. So there's a bunch of reasons why the LEDs are probably the reasonable answer to which lamps produce the least pollution. However, if you actually really want to dig deep into it, there's quite a lot of weird stuff in LEDs. There's a lot of metals and things, and the process of making them is actually a little bit at question in terms of, they're essentially computer components, if you will, and then they have the same sets of issues that all the people who are making iPhones and computers and all those things have, which they have all these sort of odd, hard to find materials in them, and the clean room process of that stuff generates a lot of pretty nasty stuff. So if you're looking at it in a really big picture way, LEDs actually have some complications. Fluorescents are pretty good in terms of their efficiency. People talk a lot about the LEDs, but I actually don't think if you really tested apples to apples, I think they're pretty much neck and neck between fluorescents, HIDs, and LEDs. So all of those are pretty efficient. So then comes the question of, well, what does efficient mean? And efficient really is the term of use, the term of art for lighting efficiency is efficacy. And that idea of efficacy is I have a certain amount of watts and I'm generating a certain amount of lumens. And so anything that I can use sort of a smaller number of watts to get me to the lumen amount that I need, that's the smallest number of watts, this is the smallest amount of power. That's what I'm looking for to do, is I want to get the lowest watts to get the maximum lumens. But when it really comes down to it, architects don't really care about lumens. Lumens are the amount of light leaving a luminaire, the amount of light leaving a fixture, right? So it's important, but what architects really care about, engineers care about lumens. What architects care about is foot candles. So foot candles is how much light is actually hitting a square footage of surface, of desk, of reading materials, of the walkways, of the walls with the paintings on them. So what we generally care about is, does the light get to where it wants to be? And so I can potentially have a very efficient watt to lumen ratio, but if it creates a really bright light that's going to be glary and blinding, then I'm going to put a shade over it. And then just by putting that shade over it or that diffuser over it, I have immediately lessened the actual foot candles that are going to get to the desk for my ability to read. So these things get very complicated. I suddenly have to have more lumens coming out because I still have to shade them or dim them in some way to make it more pleasant for me as a user. So it's a complicated thing. The main thing that I would say is think about what the question is actually asking you. What's the point of what they're talking about? For example, CFLs, compact fluorescents, very reasonable, very efficient, use very low levels of power of watts in order to generate a fairly high lumen count. And the way that they're doing the phosphors these days, you can actually get pretty good range of color, light color. But compact fluorescents, like all fluorescent systems, the way that the fluorescent works is there's a tube, there's an electrical arc that goes through that tube. That electrical arc stimulates some mercury that's in the tube. The mercury then gives off UV light, and the UV light then, which we can't see, so it's not useful to us, makes the phosphors that are on the tube, the glass tube itself, light up. So it's this very weird process that it goes through that whole big thing. But like I said, it's very efficient, but you may have noticed I said mercury. So that means every time you throw out a CFL into the garbage, there's a little tiny bit of mercury that's going into the landfill, that's going into the water table. And we are sort of slowly poisoning ourselves through this. In the old days, when fluorescents were always just the 4-foot or the 8-foot tubes, and that's how people used fluorescents, and they were all in schools and in office buildings and things like that, there was always a janitor or somebody who took care of it. And so they would take them down and give them back to the people they bought them from. And so it was very controlled. Once it became sort of a popular out in the field thing, like everybody's house, everybody's grandmother has CFLs in their house now. Well, now that ability to control the recycling isn't going so well. So again, it depends on how the question is coming at you. If it's something about things like mercury or the way that recycling systems work, CFLs are a real problem. But in the big abstract, CFLs are very, so much better than incandescents that they're a great, great resource for the country. So it's complicated.
Well, thank you, Mike, and thanks again to all of you who tuned in and who have submitted their questions today. If you'd like to attend our next a.r.e. live broadcast on the structural systems exam, visit blackspectacles.com/podcast to register to attend. And just like today's episode, you'll have a chance to ask questions and share your answers with Mike for live feedback during the broadcast.
And if I can just toss in, if you have a particular topic that you think would be good to cover on that, let us know. If you let us know early enough, we'll make sure we get it in there for the discussion next time.
Yep. And to learn a little bit more about our AIA a.r.e. prep curriculum, go to blackspectacles.com where you can try out any of the free courses. And for those of you who are ready to start preparing for the ARE, and if you're already an AIA member, as a part of our partnership with the AIA, you can visit http://bksp.es/ARE-prep826 to get a 15% discount of your AIA a.r.e. prep membership. Finally, please leave a comment below the video to let us know what you think and share any suggestions you may have. I promise we'll read every word that you write and use them to tune our next episodes. So thanks for watching.